So welcome back. We're going to revisit multiplying decimals. Again, we're going to introduce this with again, positive and negative numbers as well. So when we multiply, again, just leaving the negative out, if I have a 5.5 times 4.87, we've kind of learned that I can actually treat this like whole numbers. So that 5.5, I can change to 55 as long as I multiply that by 1/10. Because multiply by 1/10 essentially makes that decimal back to 5.5. So this expression represents 5.5. Times then, I have 487 times then, notice that I moved the decimal out 2 places, so I have to multiply by 1/10 twice. Multiply by 1/10, multiply by 1/10. So what we see here is the real math is really just 55 times 487. So I could go using old school 487 times 55. Do the math like that. So 5 times 7 is 35. Carry my 3. 5 times 8 is 40. Plus 3 is 43. Carry a 4. 5 times 4 is 20. Plus 4 is 24. Put a 0 there. 5 times 7 is 35. Mark that out. Carry the 3 again. 5 times 8 is 40. Plus 3 is 43. Mark that out. Carry a 4. 5 times 4 plus 4 is, 5 times 4 is 20. Plus 4 is 24. And we add those two partial products together and get 5, 8, 7, 6, 2. So when we do this math, we end up with 2, 6, 7, 8, 5. But notice how we still got to multiply by 1/10 times 1/10 times 1/10. But each time you multiply by 1/10, that essentially moves the decimal 3 places back to the left. So that gives me 26.785. Also got to remember that a negative and a negative are like little light switches. So that means to take the opposite, and that means to take the opposite again. So it goes from a negative back to a positive, and therefore we end up with 26.785. So remember, even and odd, when it comes to multiplying positive and negative numbers. If you have an even number of negatives in multiplication, it actually becomes a positive. If you have an odd number of negatives in multiplication, it actually goes to a negative. So what we learn is when you multiply decimals, you essentially take the decimal out and then put it back in. And notice how there's 1, 2, 3 numbers behind the decimal. That tells you how many numbers to slide the decimal. So when I come to question number 2, the way I can do this is I can actually go 116 times 5,928. So that may take a little bit of math here. So 5,928 times 116. So that's really the math that we're looking at. So old school, we go 6 times 8 is 48, carry the 4. 6 times 2 is 12, plus 2 is 16. Carry a 1. 6 times 9 is 54, plus 1 is 55. Carry a 5. 6 times 5 is 30, plus 5 is 35. I'm going to go ahead and just erase these now, get them out of the way. Start my next row. Put a 0 in. 1 times 8 is 8. 1 times 2 is 2. 1 times 9 is 9. 1 times 5 is 5. Now since this is the hundreds place, you have to use 2 zeros because you're out to the hundreds place here. 1 times 8 is 8. 1 times 2 is 2. 1 times 9 is 9. 1 times 5 is 5. So then we have to add all that together. So that's not so bad. 8. There's a 14. Carry a 1. 6, 8, 16. Carry a 1. 6 plus 9 is 15. 17. Carry a 1. 4, 9, 18. Carry a 1. That'd be a 6. So we have a 6, 8, 7, 6, 4, 8. And if we pay attention that I threw away 1, 2, 3, 4 decimal places, I now have to put those 4 decimal places back into the problem. So 1, 2, 3, 4 decimal places, I end up with 68.647648. So in other words, 68 and 7,648 10,000ths. So 68 and 7,648 10,000ths. We also pick up on that a negative and a negative make that a positive. Again, if we have an even number of negatives, it's like a light switch. That tells me to take the opposite, and that tells me to take the opposite again, so you're back to a positive value. That took a little work. So we don't want to do too many of those. Usually it's just too much busy work. We usually probably use a calculator for one like that. This one, though, not really calculator worthy, just like this one really wasn't. Now, remember in multiplication, order doesn't really matter. So instead of multiplying that negative 4.04 first, since these two are both whole numbers, I would go ahead and just multiply 9 times 3 and get 27. And since there's one negative there, that's just going to be a negative 27. Now I can go about multiplying this as whole numbers. So instead of using that 4.04, I'm going to use 404 times 27 and do my math. 7 times 4 is 28, carried by 2. 7 times 0 is 0, plus 2 is 2. 7 times 4 is 28. So I'm going to erase this and reload to the next row. Put my 0 in from a place value because that's in the tens place. 2 times 4 is 8. 2 times 0 is 0. 2 times 4 is 8. Add my two partial products. 8 plus 0 is 8. 2 plus 8 is 10. Carry by 1. That makes a 9. That makes a 10. So in my problem, we have then 10908. And there were two numbers behind the decimal that I threw out. I got to put those two decimal places back in. I also got to pay attention that I had here a negative and a negative. That's going to make that, again, a positive value. So I have 7.8 times 5.1. I can just ignore the decimal and say, hey, it's 78 times 51. And do that math. 1 times 8 is 8. 1 times 7 is 7. Put the 0 there. 5 times 8 is 40. Carry my 4. 5 times 7 is 35. Plus 4 would be 39. So we have an 8, a 7, a 9, and a 3. So when I do this math, 3978. I lost two decimal places, so I'll put those back into the problem, 39.78. And again, if you use estimation, 7.8 is close to 8. 5.1 is close to 5. 8 times 5 is 40. So the answer should be pretty darn close to 40, and that is. So I feel pretty good about that answer. So there's a little review of multiplying some decimals. Stay tuned.